All right, this lesson is is on composite functions, which is the last lesson on function operations for chapter 10. So a composite function is the substitution of domain values of one function into another. So we'll see a couple of ways that we can do this. And just like with the other function operations where we had to work with a table of values or work with a graph or work with the equations themselves, the same will be true here. So for example, given the function f of x, which is negative 2x plus 1, so linear function, the f of negative 3 means negative 3 for x in the function. So here I've replaced this x with negative 3, that's the f of negative 3, and negative 2 times negative 3 is 6, plus 1 is 7, and there we have it. So this is really corresponding to the point negative 3, 7. So x is negative 3, the f of x gives me the y value here. So that's that point. So the composition of f of g of x, that's this, is the substitution of the equation g of x, which is on the inside, into f of x. And so we can write a composition of functions like this, or like this. So the difference is that this is an open circle, and an open circle means f of g of x, and a closed circle like this is not the same. So I have is not equal. This is a product function. So you have to watch for that. Am I multiplying them, right, a product function, or is it an open circle, a composite function? So let's look at a couple of examples. And again, the sort of skills here are doing a composite function or a product function or a quotient or a sum or whatever. First, using a table of values. Then using a graph, which is really the same sort of thing. We're reading the same values, just instead of from a table, from a graph. And then the other one is, doing the algebra with using the equations of the functions. So those are kind of the skills in this lesson. Right, so in these examples, we're going to replace the values of x and then substitute. So here, we're first asked to evaluate the f of the g of negative 1. And over here I have a table of values, this first one for f of x, and then one for g of x. And so really our trick with all of these composite functions is start with the inside. Okay, so that's my hint. So the inside over here, with this guy again, is the g of minus 1. So what does that mean? Well, it means I'm using the g function, g of x, and x is negative 1. So that is right here. So the g of negative 1 is actually 2, right? When x is negative 1, what is y? Y is 2. And now I'm going to replace that right here. The g of negative 1 is 2. So what this question is really asking is for the f of 2, this value. G of negative 1 is 2, so I replace it. And now I'm looking at the outside, f of 2. Well, now I'm using the f table. What is the f of 2? 0. So the f of the g of minus 1 is really the f of 2. That came from here. And then I put it into the table of values, and I see, or I read it off the table of values, rather, and I see that it's 0. So the first one is 0. So this might be a good point to pause the video and try these two. Start with the inside, find the value, and then put it in just like I did. Okay, so here, hopefully, this one, you saw that we start with the inside, which is f of 1. What is the f of 1? Let's get rid of all this mess that I have here. Oops. There we go. The f of 1 is negative 1. So this is really saying the f of negative 1, because this inner bit is negative 1. What's the f of negative 1? 3. So this equals 3. So I can conclude the f of 1 is 3. And down here, this, I should have put a bit more space there, but this is the g of the f of 2. So if we just clean this up again, there we go. I want to start with the inside, the f of 2. F of 2 is 0. So now I'm going to replace that with this value. What is the g of 0? Now I'm using the g table of values, and the g of 0 is 1. So the g of the f of 2 is 1. And that's the answer for that. So hopefully you got those ones. All right. In this one, we're doing essentially the exact same thing, except instead of reading the values off of a table, now we're reading them off of the graphs of the functions. So f of x is shown here in red, this one. This is f of x. And the linear function in blue is g of x. And so we're asked first to find the f of the g of negative 2. So remember, the g of negative 2 really means on the function g, when x is negative 2, what's y? So I'm going to look for x being negative 2, that's right here, and I'm going to find what is the corresponding y value on the g function. And I can see that point right there is negative 2 comma 8. So this is really 8. So what is the g of negative 2? It's 8. So now I'm going to substitute that back in here just like I did before. So the f of 8 is what I'm really looking for. So now I'm looking on f of x, which is this function, 8. I go up, and that is 3. So this is 3. So I can say then that the f of the g of negative 2 is 3. Okay? And this one, why don't we pause here and give this one a try too? Okay, I'm just going to clear this up so I have a clean graph to work on. And first, I start with the inside. F of 3 is what? And again, that means on f of x, which is this guy, this function here, when x is 3, what's y? Well, I go over and read that. Here's 3 between 2 and 4. I go up, it's 2. So, because this is 2, I'm going to replace that in here. And the question is really asking for the g of 2. So now I have to read on g of x, which is this line. 2 is right here on that blue line. So the g of 2 is 0. So then the g of the f of 3 is really 0, and that's why. So there's our second skill, using a graph. Our first skill was using a table of values, but it's really the same thing. Okay, we're just replacing in a function. And now, third skill, we're using the functions. So my first function, f of x, is an absolute value. So hopefully you remember that from last year. And g of x over here, I've got 1 over x squared plus 1. So I'm determining the f of g of 2. So I have to figure out what is the g of 2. And instead of reading it off a graph, I have to do a bit of algebra to figure it out. So the g of 2 is going to be 1 over 2, I replace the x squared, plus 1, which is 1 over 4 plus 1. And so the g of 2 is 1 over 5. And now I'm going to replace that in here. So the g of 2 I found out was 1/5 by doing some algebra. And now this question is really asking for the f of 1/5. So now I'm going to use this function, and the f of 1/5 is the absolute value of 1/5 minus 1. Okay? And I'm subbing that in for this x, taking away 1 and then taking the absolute value. So the f of 1/5 is the absolute value of 1/5 take away 1 is really like 1/5 take away 5/5. So that's going to be -4 over 5 in the absolute value signs, which hopefully you remember takes away that negative sign. Tells me what is the distance from 0? Well, this is 4/5. And that's the answer for this side. So maybe try this one. Pause it here, try the f of 2, find that, and then put that value into the g function. All right, so let's do it together just to make sure you got the right answer. So the f of 2, first, I start on the inside, is the absolute value of 2 take away 1. So the f of 2 is 2 minus 1 is 1. So the absolute value of 1 is 1. So now I'm going to put this into the g function. So this is really asking for the g of 1, which is 1 over 1 squared plus 1, which is 1 over 2, or 1/2. So my answer here is 1/2. All right, so those first few examples we're looking for particular points, which you'll see in the assignment later. And now what we're going to look at is doing some algebra, but finding just what is the function f of g of x. So not a particular point, but what is the function? So remember, this symbol means f of the g of x. So f of this, 3x minus 5. So my two functions are a linear one, that's g over here, 3x minus 5, and a quadratic. So f of x is x squared plus 3x. So it means anywhere I see that x, so it was x squared plus 3x. Anywhere I see that x, I'm going to replace with this function. So I've got 3x minus 5, where this x was, squared plus 3 times this x, which is really 3x minus 5. And then I just kind of have to do some algebra to clean this up. So remember that when I square a binomial, this is not just 9x squared minus 25 or plus 25. I like to write it out twice and do FOIL, so that I don't make any mistakes and I don't miss anything there. So this is going to be 9x squared, when I times here and here. This is minus 15x, another minus 15x, and then a plus 25. And then the second bit, I distribute the 3, and I get plus 9x minus 15. So if I clean all this up, I should get 9x squared minus 21x plus 10. And so this is, and I'm just going to write this here, f of g of x. So f of g of x is this. All right? Down here, we're putting g into f. So again, the order is important. This time we're doing the g of f of x. And if I go back up to see that, f of x is x squared plus 3x. So g of x squared plus 3x is 3x minus 5. Oh. Let's look at that. So originally my function is 3x minus 5. So anytime I see this x, I'm going to replace it with what I have in the brackets. In the past, that was always a number. Now it's a whole function. So 3x squared plus 3x, this goes in for x there, brackets, minus 5. So I have to do a bit of algebra here. Distribute there and there. And there's my function. So this is the g of f of x. All right? So in this one, I'm putting the function of x into the function of x. So I'm not dealing with g at all. I'm going, what is the function of x squared plus 3x? Remember, originally it was x squared plus 3x. So this x is going to be replaced with that, and this one too. So I'm going to have x squared plus 3x squared plus 3 times x, which is this function. And then we just do a bit of algebra to clean that up. So again, I have a binomial that I'm squaring. X squared plus 3x times x squared plus 3x plus this bit. So if I FOIL this, I'm going to get x to the power 4 plus these guys. Yep. Plus 9x squared. And then over here, I distribute this to there and there, and I get another 3x squared and another 9x. So if I combine all of this, I have an x to the power 4. I have a couple of these, so 6x cubed plus this 12x squareds and a 9x. Okay. From here, here we're doing kind of another layer onto that. So I've got the f of g of a plus 2, which is another sort of function, if you will, a plus 2. And I've got f of x and g of x, a quadratic again, a linear. And so I'm going to start with the inside. Remember, this means f of the g of a plus 2. So I'm going to start with this. What is the g of a plus 2? Well, it means I'm going to use the g function, and whenever I see this x, I'm going to put in a plus 2. So the g of a plus 2 would be negative a plus 2 plus 1. So that's negative a minus 2 plus 1, which is negative a minus 1. So that's the g of a plus 2. And now I'm going to put this into f, because we figured out that this inside bit was negative a minus 1. So I'm really looking for the f of negative a minus 1. And that will be now using the f function, which is x squared minus 2x. So x is this squared minus 2x. And again, I have a bit of algebra to do to figure this out. So I'm going to write this out. Oh, oops, let's get rid of that. Try that again. I'm going to write negative a minus 1 times itself minus 2 times negative a minus 1. So we've got lots of negatives to watch here. Negative a times negative a is positive a squared. Negative a times negative 1 is plus a, plus another a, plus 1. And here, negative 2 times negative a is plus 2a. And negative 2 times negative 1 is plus 2. So if we go back to what we had, it was the f of g of, instead of x, we had another function, a plus 2, just another layer of fun for you there, a squared, and it looks like I've got 4 a's here, plus this 1 and that 2 is 3. So that would be the f of g of a plus 2. Instead of x, it's an additional function. So give this one a try. Start with the middle, or the inside, that is. So what is this? F of x minus 1. So put that x minus 1 in here and square it, and in here and times it by negative 2. Clean that up, and then put it into the g function here where I have negative x plus 1. So this might be a good point to pause and try that. All right, let's do it together then. Oops, there we go. So the f of x minus 1 is where I want to start. And that is x minus 1 squared, where this x was, minus twice x minus 1. So I'm just going to skip through the FOIL here and do that sort of quick, minus 2x plus 1, minus 2x plus 2. So this is really an x squared minus 4x plus 3. So hopefully you got that. And then this, because that is the f of x minus 1, means I'm going to put that in for g, right? It's replacing this. So what is the g of x squared minus 4x plus 3? Well, that would be, using the g function, negative x, which is this trinomial, plus 1, right? It's negative x plus 1. Negative, this is our x, plus 1. So that negative sign is going to flip all these signs. Neg x squared plus 4x minus 3 plus 1 is negative x squared plus 4x minus 2. So hopefully that's what you got for the g of f of x minus 1. All right. The next bit is about domain, but I think I'm going to go over that with you in class. So let's stop here, and then you can start on the homework.